All right. So systems of linear inequalities is what we're going to talk about today. And solving those, graphing is a definitely the method we're going to use to solve those, because linear inequalities don't just have one answer. Systems of them don't just have one answer. Okay? If they have answers, they're going to have an infinite number of answers every time. Okay. When we're talking about linear inequalities, we'll just start with something simple here, like y is greater than negative 2x minus 5. And then the other one, let's do y is less than or equal to x plus 3. A couple of pretty simple linear inequalities for our first example. With linear inequalities, if we're going to graph them, we still get them in what form are these in? Slope-intercept form. That still looks like it's not changed any since you did this in Algebra 1. Okay, so if you're going to graph these, they're already in slope-intercept form, so we need a grid here. So I'm just going to draw myself a coordinate plane. Those make your axes right on the grid lines, make them real nice, straight. So a straight edge is handy. Hold up a piece of paper if you don't have a ruler or something. It'll make a straight edge. And let's just start with the top one. And where do we start when we're graphing y is greater than negative 2x minus 5? The minus 5, where? On the y-axis. So I'm going to graph this one with a blue pen, just so if I say the blue one or the red one, you'll know which one I'm talking about. So I'm going to negative 5 on the y-axis. 1, 2, 3, 4, 5. Okay. And then the slope is what? Right one. Thank you. Because it's a negative slope. And remember, negative slopes always go down and to the right. Okay. So whether I count down to right 1 or up to left 1, I'm still getting a negative slope because it's going down and to the right. Okay. So I'm just going to give me another point there just so I can draw a better line. Now, here's where the difference in graphing inequalities and just equations happens. Because it's a greater than symbol, what kind of line do I draw? Dotted. Thank you, Connor. That's right. It's a dotted line. He said it first. Several said it. But so a dotted line because it doesn't have the equal to mark. If it's got the equal to mark, what kind of line is it? Solid line. Okay. So dotted line. Now the bigger question is, what does that dotted line mean about the points on that line? Very good, Myra. They're not part of the solution. Okay, so the dotted line just means that any point that's on this line is not part of the solution. Okay, so we've got to know that, because if they ask us to test a solution, they give us an ordered pair. If it's on that line, we know, hey, I don't even have to plug it in. It's on that line. I know where it's at. It's not a solution. Okay. All right. Now, next thing that happens with that is what? Somebody remember? Shading. Got to do some shading on that. And there's different methods for deciding which side to shade. I am a test point person. Folks that had me for Algebra 1, you've done this before. If you had somebody else for Algebra 1, they may have said, oh, if it's greater than, you go above it. If it's less than, you go below it. Well, that's when the line gets a little more vertical, it's harder to tell which side is above and below, right? And so I'm a test point person. I like to just check a point. So I take the origin, if at all possible, because that's the easiest one to check. 0, 0. I can always multiply. I know my zero multiplication table is better than any of them. So I can plug 0, 0 into the equation or inequality. 0 greater than negative 2 times 0 minus 5. Is 0 greater than negative 5? Yes. So that means it's true where the origin is. So that means the shading for this line goes toward the origin. Okay, so that's how I do that. And if you do it a different method, as long as you're getting them correct, I'm okay with that. But there's some shading on that side. Just lightly shade it with your pencil. I'm using colors there because cool things happen. All right. So there we have one inequality graph. Let's graph the other one and determine where the solutions lie for this system. Okay. So where do I start with this inequality? 3 on the y-axis. Remember, y-axis is up and down. We're going to 3. We're putting our dot. Slope is how much? 1. So what do? Up1, right 1, or down 1, left 1. We can do either one. Solid or dotted? Solid, because it's got the equal to mark. That tells us to put a solid line. Nice solid line there. Now, shading is the last thing that has to happen. Well, before we do that, what does the solid line mean in comparison to the dotted line for the other one? Yeah, the solid can't, those points on that line can be part of the solution. So it's okay if it's on there and it's in the shaded area. Okay? So shading for that one, less than. So I'm going to check the origin again because I'm a test point kind of guy. So 0 less than or equal to 0 plus 3 is 3. So is 0 less than or equal to 3? Yes. So it's true on the origin side. If it were false on the origin side, I'd shade the other side. If it's true, I'm going to shade toward it. Okay, so I'm going to shade toward the origin. So all that. Where are the solutions to the system? Yeah, in the overlap area. Yeah, that where both of them are shaded. So you guys, it'll be the darkest region of your graph. Here, mine is in the green area, because the yellow and the blue overlap to make green. Okay, so all the solutions for this system are in that green area. Okay, so that means if I picked an ordered pair in this green area, what will it do in the inequalities? Be true in one of them, both of them. Just like an ordered pair in a system of equations would be true in both of them. Okay, so if they ask you to test a point, if it's a solution, you're going to do the same thing we did with equations. You're going to plug it in and see if it's true in both of them. If they ask you to give an example of a solution, then you're going to pick an ordered pair that's in the overlap area. Okay, overlap is where the answers are. Is there always overlap? No. If the lines cross, then yeah, there will be somehow some overlap. If the lines are parallel, in equations, if the lines were parallel, what was the solution? No solution. That's not always the case with inequalities, because they could shade into each other and the area between the two lines can be a solution. So lot more going on with inequalities. Let's look at another one here and kind of refresh you on some. For whatever reason, these are the most simple inequalities, but it always gives people trouble because they forget. That's a -3, by the way. Sorry, missed my negative sign there. And then x is greater than or equal to 5. These always give people trouble because they just forget how to graph them, because they're not like example A. They're not slope-intercept form equations. So how do we graph y is less than or equal to -3? It's got no slope, but what does no slope mean? Horizontal line? Okay. Where at? Oh, -3 of the y-axis. Okay, so just being very descriptive. So if it's y and a number, you're going to go to that number on the y-axis. Put a dot. And then, as I said, horizontal line, which is true. Horizontal line, zero slope is the same thing. So is it a dotted or a solid horizontal line? Solid, because why? There's not such a thing. Greater than or equal to or less than or equal to. Which one is this? That is less than. And the way, if you have trouble telling the difference in less than and greater than, put your left hand out in front of you. Okay? I'm with you here. Look at my left hand. Make an L with your finger and your thumb. And turn it sideways. Does that not look like a less than symbol? Yeah. It's an L, less than. Okay? So if you have trouble remembering that, think, okay, it looks like this. Oh, that's an L. That's a less than. Okay? Greater than is the other way. Okay? Please don't say alligator left and alligator right. That bothers me. Nothing against alligators. Has more to do with actual math knowledge and not ignorance. Okay. Now, shading. Where is less than negative 3? Below it, right? These are easy to shade because if it's less than, it's going to be below it, right, on the y-axis. So all the shading would be down here. Okay, so we're going to shade below that. Okay. Let's go to x is greater than or equal to 5. X and a number, what kind of picture are we going to get? A vertical line. So y and a number is horizontal line. Vertical line comes with x and a number. So we're going to go to 5 on what axis? The x-axis, because that's what letter there is, x-axis. So we're going to go to 5. 1, 2, 3, 4, 5. It's going to make a vertical line. A dotted or a solid vertical line? Solid vertical line. Okay. All right. Shading is the next thing. It says x is greater than or equal to 5. So where are the x values greater than 5? To the left of the red line or to the right of the red? To the right. Okay. So greater than is this way. So we're going to shade this side. And the overlaps is going to be this corner down here. That's where the solution area is. Okay. And we know that this area extends on down, indefinitely. It never stops. Okay, so that solution area is there. And my question to you for this one, just extending a little bit, is the ordered pair 7, -5 a solution? Why? It's in the shaded area. 7 will be over here, -5 down right there. Right there. It's in the overlap area. Also, it also works in the inequalities. If I plug in x, 7, the only place there's an x is right there. 7 is greater than 5. That's true. And if I plug it into the inequality here, there's only a y, so I'm only plugging in the -5. -5 is less than -3. So it's true in the inequalities. It's also in the overlap shaded area of our graph. Okay, so really, really easy thing. Okay, any questions about inequalities?
I don't see where 7 -5 came from.
I just made it up. It was just an extra question. Is that ordered pair a solution to that system? That was like that, buddy. Let's call that example C. That helps us. And we said it was because it landed in the shaded area over here, right there. 7, -5. And you can hardly see that orange and that green.
Like Tennessee national championship. Not there very. You'll see it very often there. So.
Maybe. Coach Pruitt's going to get us there, though. We know it. We know he's going to get us there. All right, let's do one more, and it'll be the end of the day. I don't know how many of you are Tennessee fans in here. I am, but I'm also a realist. So, all right, let's throw a little kink in things and make it more fun. Let's say we had 6x minus 2y is less than 8. And the other equation in the system will be 2/3 x minus or plus. Let's make it up here. Let's do 1/3 y is greater than or equal to 2. Good one. So if we're going to solve that system, and we're going to graph it, if you're asked to solve a system of inequalities, graphing is the solution. That big graph is the answer. Okay? When you go to Khan Academy with our assignments, they're going to have graphs drawn there, or they're going to ask you to draw the graphs out of that. So it's going to be this kind of stuff. Now, what do we have to do first? So get y by itself, slope-intercept form for both of the inequalities. So I'm just going to start with the top one because doesn't have fractions in it. It looks like it's easier, right? All right. So what do we do? Subtract 6x. So that's going to be negative 2y is less than negative 6x plus 8. And then what? Divide by negative 2. All right. Good. We're good at this stuff, right? So everybody gets divided by negative 2, not just the 6, not just the 8. Everybody gets divided by the negative 2. Okay, I didn't put the inequality symbol there. There must be something up with it. Mr. Isbell doesn't really ever do. Victoria, can you help us? Yeah. Very good. If you divide by a negative, also if you multiply by a negative, we divided on this one. If you multiply or divide by a negative when solving an inequality, you have to flip the symbol around. Okay, so the less than becomes greater than in this case. All right. So now we have that inequality, and we're going to graph it in a minute. Let's go ahead and do the work, get the other one in slope-intercept form, and then that way when we get in graphing mode, we just go. Okay. What do we do first? And subtract the 2/3 x. Good. So we have 1/3 y greater than or equal to negative 2/3 x plus 2. We got a fraction in there. Everybody loves fractions, yeah. If you don't like fractions, bring me all the pocket change you get every day when you go to Walmart or whatever. And because that's a fraction of $1 and you don't like fractions. So bring me all that. I'll take it. And eventually have enough to retire in about 30 years. All right. What do we do next? How do I get rid of the 1/3? Divide by, or what y'all saying, multiply by the reciprocal. Yeah, that's the word I was looking for, was reciprocal. So flip it, multiply. So 3/1 is just 3. So I'm multiplying that whole side by 3. And y. Do I flip my inequality symbol on this one? I saw yeses and nos and some of these figure 8 looking things. So which one is it? What am I multiplying by? A positive 3. So that's not a negative. So I'm not going to change it. It doesn't matter what's over here. even though there's a negative number there. That's not what you test by. It's always what are you multiplying or dividing by. So I'm multiplying by 3, which is a positive number. Now, what's 3 times negative 2/3? Negative 6 over 3, which is negative 2. And then 3 times 2 would be 6. So now we have those two beautiful slope-intercept form inequalities that we can graph on the coordinate plane. And I am going to go over showing you on the graphing calculator how you can get it to do some of this stuff. Without an app, I'm not going to entertain the idea of using an app on the calculator. It takes no knowledge to use an app. It takes knowledge to use the actual graphing tools. And technically, you're not supposed to use the apps on the graphing calculator on ACT and stuff. So I would. Well, I understand that too, but they're supposed to disable those when you go to test. Most places don't, but I would hate for you to learn how to do it with an app and then you go somewhere like you. I know we've had some band students that have had competitions somewhere on a Saturday and they needed to take the test close to where their competition was so they could make it to the competition. And different places, the administrator will, they can apply the rules the way they do. Most people around here don't disable the apps on the calculator. Some places do. So I want to show you how to do it the right way. So let's graph it by hand and then we'll graph these with the calculator. I'll show you how to do that. All right. First one, green one. Where are we starting? -4, up 3 over 1. Dotted or solid? If I test the origin, is 0 greater than -4? Yeah, so I'm going to shade left side of that line. If I had not flipped this inequality symbol when I was solving it, which side would I have ended up shading? The other side had been wrong. So that's where that can get you if you don't do it.
How again do you clarify whether it's a solid line or a dotted one?
The inequality symbol, if it's got the line under it, it's got the equal to mark under it, it's solid. If it doesn't have it, it's going to be dotted. Okay. Get the last one there. We're going to 6. Oops. 6. 1, 2, 3, 4, 5. 2, 4, 6. There we go. A slope of -2. And this one would be what kind of line? Solid, because it has equal to mark. And then shading wise, is 0 greater than +6? No. So I'm going to shade this side, the bottom side or the top side? Top side, because we're going away from the origin because it wasn't true. So we're going to shade this side. And that triangle up there, V shape, that's where the solutions are at. Okay. Nice. All right, I'm going to show you with the graphing calculator how you can graph those.
So let me just figure this out here. So with the second one,
Perfect. Okay.
so did you get 3 as the y-intercept by simplifying it? Or?
No, the y-intercept here is 6.
Oh,
so I went up here to 6. 3 is the x-intercept. The y-intercept number is the vertical. That's okay. It's all right. Get you straightened out. All right. Anybody else got a question about this one? All right. Graphing calculator. We're going to the graphing portion of your calculator. So hit y equals to get to this page. Y equals top left button right underneath the screen is the y equals. That's where you'll type in your inequalities or equations. So we're going to type in those slope-intercept forms of those inequalities. we've got an equal sign here, so we're going to do something to make that better in just a little bit. So 3x minus 4, so I'm just going to type in 3. Remember, x is beside the alpha button, minus 4. And then the other one is, what was it? Negative 2x plus 6. Negative 2x plus 6. And if I hit graph, I get the 2 lines, but I don't have any shading happening. Okay? So to get the shading on the calculator, you've got to think, okay, well, if it's greater than or less than, I can change that. So if I've got the newer one, if you've got one of the color ones, press the left arrow over here. If you've got one of the black and white ones, press the left arrow until you get to where it's got the little line. Okay, the color ones will have a color block there beside the line, but they still got the line. I'm going to hit enter, and then I could change the color if I've got a color one. If you got the black and white one, does y'all's pop up a menu? No? Okay. When you hit enter with the black and white ones, it's going to change your picture to a triangle. Looks like that, right? If you hit enter again, it's going to change it to a triangle at the bottom. And if you hit enter again, whoops, it'll change it to this weird looking thing. That doesn't matter. We're not using that. Or the circle. We're not using that either. Okay. And then here's a dotted line. Not that that matters. We're not using that either. There's a more separated dotted line. It has a lot of options. And then we're back to the top where we got a regular line. What we want is one of the triangles, either the top triangle or the bottom triangle. Okay. If we're shading the first one there, the Y1 is it less than or greater than? Look back. It was greater than. Okay. So that would be the top triangle. Okay. Okay. And let's look and make sure it graphed it correctly. Right? That's the picture we drew, right? Greater than. Go back to y equals. Go to y2. What was its inequality symbol? Less than or equal to. Okay? The equal to part we can't do anything about with the calculator. We've got to just deal with it. So we need the triangle that's less than is the one on the bottom. So I'm going to hit, for this one, I'm going to hit enter. If you've got the black and white version, you're going to just hit enter until you get that triangle at the bottom. And then hit graph. There's the first picture. Whoops, hold on. Okay. It wasn't a less than, it was a greater than. Sorry. No wonder. I need the top triangle for both of them.
May I have your attention, please? Senior yearbook ad forms are in the office. They are due August the 30th. They will not extend the deadline the due date.
There we go.
So
Double greater than, we got that V shape in the middle. So you can verify things with the graphic calculator if you want to. Tomorrow, I've already assigned
school whose due voting has begun.
if you want to get
You will
started.
need to vote for your
Tomorrow, you'll have work
student
day class
email.
to work on that stuff.
You may vote through
And we'll go from
tomorrow.
there. I know that there's a junior
Seniors, you
class
need to go
meeting
to your
tomorrow
Magnet
morning.
student email to vote
At
for
some point, I don't know how long it'll take, but
This
at what
will
time they'll
determine
call
who
you.
your queen
But
is.
tomorrow
That's
morning,
just for
junior
seniors.
class, you guys have a meeting, so
Do
don't skip
that
on Friday.
until
'Cause
tomorrow.
It's fairly,
Any
anytime they
senior
call a
who
class
forgot to
out
turn
of
in their
that
classroom
class,
order
it's
may turn
important.
it
So
into the main
be here for that
office.
meeting.
They will come back by in the morning to pick those up.
All right, we use
Students, please check your email for an important survey about our after-school program.
Get entered.
The hostess sign-up sheet is in room 118. These are $15. High school students who need to sign up for senior beta club need to see Ms. Valerie in the library. Any student who does not want to use their locker, please Megan in the front office. We have
That
students
600 came back
that
to the default,
would like to have it.
the original settings.
A student interested in going to London, England in June of 2019. Students majors in grade 115. Admission card will be tonight at 5:30. Tickets are $5.
Those are two different
All players
things.
or a cheerleader. Anybody who needs a parking pass for school will need to see Ms. Waller this week.
We'll work on it, okay? Thank you, sir. Thanks. Hey, Gavin, you might stop by and see if Coach Mack might have some batteries that you could get.
Jonathan White, Justin White, and Benjamin Suter to the